We talked in the last video clip about providing lifecycle management for Blackwell Compute. We talked about looking at physical asset collateral associated with the Blackwell chip and the Blackwell Compute. Things like looking at the GPU from a standpoint of physical asset collection, uh, looking at standard out-of-band management for telemetry and sensor data we can collect from the CPU itself. We also talked about performance metrics and how we've defined a customized dashboard for those DevOps administrators to collect that vital information on how well their models are performing and being able to determine or get a holistic view so that they can make those data-driven decisions associated with the server. So we're going to move on to another area which is important from an enterprise perspective with all the concerns about energy consumption and having not enough power on the power grid. PDU management is vital to be able to provide a unified dashboard experience for those DevOps administrators. And so we're going to continue on with the PDU management segment of this. One of the things I want to talk about is we've been working and collaborating very closely with Schneider Electric, the leading manufacturer of PDU and also electrical solutions and energy solutions for a data center, and how we're building in a universal agent to be able to support automatic shutdown of link detection for many of those PDU manufacturers in the industry. But our focus today is really on what we've built with a essentially a customized rack scale design for B200 use cases, and how we have now utilized the innovation of a cutting edge PDU design that we're going to provide within all of our rack management within rollouts to AI factories. And so we're providing the necessary life cycle requirements for PDU management. And today I'm going to focus on that piece of our segment. So we're going to launch the PDU console where we provide that level of detail for collection sensor data of telemetry and analytics. So each of our PDU consoles support many of the manufacturers out there. We're focusing on this particular product SKU, which is basically customized for our rack scale design, which is our patented Supermicro rack within B200 use cases. And so Schneider's been leading the way in innovation of providing a important aspect of energy consumption, PUE, and thermal. So what we're looking at here is basically an outlet list of information that we provide within our PDU console. Things like the system power mapping, which essentially maps back to a system to indicate this particular system through tag management is connected to this PDU, and how that's going to be important of creating essentially enforcement policy for liquid cooled data centers and being able to shut down an entire rack when there is actually a leak that is basically detected. And other things associated with the outlet list are receptacle type, outlet status, the active energy that's consumed, RMS current, active power state, active power maximum, and low criticality. And we'll see in the next particular segment how you can set thresholds up for alert management when you've overutilized or overpowered a specific outlet, and what those checks and balances are in place to be able to alert against. So if you wanted to power down a specific outlet, we can simply click here and utilize the off condition, which would basically cut power to that outlet, or we could actually recycle the particular outlet, given the fact is maybe it's gone to sleep or there's something wrong with it. By being able to cycle power to it is going to be an important aspect from a standpoint of a warm boot associated with shutting it completely off based on a cold boot sequence or bootstrap sequence. The other aspect of this is you can also go ahead and shut down the entire rack for PDU power, right, as well. I'm not going to do it in this particular use case because we have active particular systems running within this environment. So other things that are important specifically for the use case is this aspect that I talked about, which is basically tag management, identifying a specific server that is connected to that particular outlet to give the DevOps administrator an oversight to understand what systems are directly connected. And this is something that you can add in based on the outlet for tag management. So in a nutshell, that's the lifecycle management of controlling the outlets. I want to mention that it's important based on having an intelligent agent that is able to collect this metadata and be able to communicate directly to the PDU controller itself. And there are many different types of aspects associated with that, such as systemoid descriptors. Not all particular manufacturers have essentially redfish built into it. We believe that the industry will continue to adopt redfish, and many of those PDU manufacturers will adopt redfish standards in their implementation. The good thing is that Schneider is ahead of that and leading the charge from redfish adoption in their PDU controllers. So I'm going to focus now on really sensor data or data collection or harvesting. And by clicking on the navigation toggle here, you simply see that the sidecar gets opened up with various different sensor data we can look at. So from a sensor reading perspective overall, it gives you a good indication of the active power and energy consumption for the inlet status itself. And then if we scroll down here, we can also look at very detailed information about line status and line voltage associated with each of the PDUs and the overall PDU controller, and various other telemetry and analytics that we're collecting from this particular PDU itself. And then also, if we wanted to look at detailed information about trending of what's going on with the inlet, you can see here that we are basically collecting that data across data points in time of this type of energy usage. So we have a little bit of a blip here in data that we've actually were able to go ahead and pull, and the developers have been doing active testing here, and that's why you're seeing a blip here and that we're not actually providing the data we need for charting purposes. I want to also mention on the top here is you can do, again, that standard historical trending analysis on energy consumption and various different telemetry you want to provide. This date picker, as I mentioned, is bolted across all of our particular data collection points for GPU performance metrics, things that are monitoring detail, which is out-of-band management, so on and so forth. So we've taken this whole entire architecture and tool and bolted it across the entire platform of SuperCloud Composer. The other thing we want to take a look at is active power. So these are things that you can set for upper critical and also upper warning. These are actually threshold settings that you can basically set and then also be able to alert on. And we'll talk about that later and how we set trigger policies up in our call home to be able to send those SMTP relay messages through mail or through SMS, or using our active webhook architecture to be able to support things that are call tracking systems such as ServiceNow, Salesforce, and that kind of thing. So being able to actively integrate, and we have that today with Teams integration and other particular chat channels out there that we can integrate with because we bolted in the foundation of webhook architecture. Moving on to the line piece of this, again, showing you various different data points for voltage that are provided here. Again, a blip in data that we're not collecting because our developers were testing. And then we have also voltage and active power provided. So this is very detailed in the data points that we're collecting, which is going to be important for the DevOps administrator to understand specifically what energy consumption and what utilization of power they're using at a PDU level. And that will be important as we continue to build the momentum on a sustainable message for Supermicro's vision of green IT. And so I'm going to go through the next line of overcurrent protector, seeing various different points that we can set for upper warning and upper critical. The delta values, we see a little bit of a peak there in basically our overcurrent, and so on and so forth. We can go down and look at additional data points for each of those protector banks, for lack of a better term. And then we also look at outlet banks, overcurrent protector of outlet, setting those data points here across time. Again, being able to trend that for over a period of delta points. You can see here the time intervals, and by scrolling across here, we can see various different kinds of points here in time as far as data is concerned here. And then the last piece is the peripheral devices, relative humidity, and setting upper limits. So we have various different sensors that can be connected directly to this PDU controller to be able to determine, sense humidity and other various sensor and telemetry that we're able to collect in a rack. That's going to be very important for the DevOps administrators. So the next particular video clip will focus on basically lifecycle management for CDU use cases, and maybe we'll go ahead and be able to tackle in or get in to water tower as well. We'll see you next time.